Start the recording. Okay, Bismillahirrahmanirrahim. Beta, here were having a question. Okay, a first object was having a momentum. This is a momentum time graph, and first object was having a momentum of 10, and the other second object was having a momentum -7. They collide with each other, and after collision, the momentum of second object is changed to +6. What will be the momentum of first object? So we never need to change our basics. We will again be using this formula m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So the momentum here, the difference here, we are told about the momentum. It means the value we are told here is the m1 u1, and this is the initial momentum second object. This will be m2 u2, right? So m1 u1 is given, m2 u2 is given, and the final momentum of second object +6 is m2 v2. Actually, we have to find this one. So beta, we don't never need to change our basic. We will be using the same formula now, substituting the values. And what are those? For m1 u1 it is 10. For m2 u2 it is -7. Don't change the formulas or signs. If you have to write anything in with my negative sign, you just write it within a bracket. m1 v1, actually the final momentum of first object we have to find. We write it as it is, and this is +6. Now you can solve, and the m1 v1 will be equal to -3. So the answer for this is -3. Right, beta ji? Done? Hassan, understand?
Yes, sir.
Okay. Beta ji, now we are going to discuss a derivation. From where the formula m1 u1 m2 u2 plus m1 v1 plus m2 v2 has come from. So beta, let us start. Consider. We are talking about law of conservation of momentum. What do you mean by conservation of momentum? How do you state
All
it?
momentum that goes in will
Total
be used.
momentum of an isolated system remains constant. Word isolated is very important, right, Suraj? So how do
Yes.
you state, Hassan? Total momentum of an isolated system remains constant. How can we check it remains constant? Beta, if we want to see momentum remains same or not, let us first change it, try to change it, and then see it remains same or not. How would you change the momentum? Ji Hassan and Suraj. Beta, we have to prove the momentum stays constant.
We either change the object's mass or the velocity.
Um, but note the real answer you should say, because isolated system means where there is no addition or subtraction of anything. Nothing, no external is there. We are having two masses now. So first of all, now I'm repeating again, beta, we have to prove momentum remains constant. How can we prove that? We will first try to change the momentum and then see it remains same or not. How would you change the momentum? So force is the rate of change of momentum, right? What is the definition of force? If it is asked from now on.
Rate of change of momentum.
Okay. So force is the rate of change of momentum, right? So we should have a force. To create a force, how many minimum objects are required?
Two
Four.
objects.
Two objects must be there because one object cannot apply the force. There must be another object to apply the force. So first of all, we will have a force, and for having force, we need two objects. So let's say we are having two masses m1 and m2, and for having their momentum, they should be moving. Let's say the object 1 is m1 is moving with the initial speed of v1 towards the right, and the second object is moving with some speed v2 towards the right. Here now, if you notice, this arrow is larger, u1, than u2. This is to show the speed of u1 is faster than speed of u2 of second object. Why? If it will be faster, then it will get closer to collide now, right? If second object would have been faster or their speed would have been equal, then they would not have come closer to each other, right? For a force to create a change in momentum, there needs to be a force, and for that, the speed of the object coming from the behind should be faster. So U1 must be larger than U2, so they could come in contact and apply force. Okay, there is a question. Hassan and Suroj. Let's say this is you and your vehicle, let's say you are traveling in this vehicle and this is moving with a speed of 100 kilometer per hour, and the object or the vehicle coming from the behind is moving with a speed of 120. You are in this vehicle, right? Consider this masses as vehicle, and you are in V2, vehicle 2, M2 mass, moving with speed 100, and a vehicle is coming from behind with the speed of 120. Surosh and Hassan, what feel the speed you will feel of this object 120 when it is crossing you or coming closer to you?
20.
20. Very well answered. You will feel the answer speed of the first object, the m1 coming from behind, that will be equal to the difference of both the forces, because you were also moving yourself with the speed of 100. So you only experience its speed to be 20. It means you will feel equal to the difference in speed of both. With this speed, the object is coming closer to you, approaching you. So, beta, the difference of these two speeds is said to be relative speed of approach. What do you mean by relative? Beta, relative means with respect to someone. Like beta ji, 1,000 rupee note. If you have a currency note of 1,000 rupee, that will be of different importance for you, will be of different importance for your younger brother and sister, and will be different for a laborer, a worker, mazdoor, will be different for a rich person. The value of 1,000 will be felt differently. And for a poor person, the value of currency note 1,000, same currency note will be different, right? So, beta, when we are telling, seeing the importance or value of anything with respect to another person or another object, that is called relative value. Here it is relative speed. Beta, this object was moving at 100 and this was moving at 120. But for this object, its speed will be felt like only 20, that the object will be getting closer with a speed of 20, which is equal to the difference of both the speed. That is called relative speed of approach. So when these two objects, M1 and M2, strike each other, collide with each other, so usually what happens? The object which was faster now becomes slower, and the slower one, which was initially slower, M2, now will get faster. Like in snooker, you strike the white striker ball to the other red or colored ball. So initially, when you hit the white striker is fastest, na? But when it strikes with the balls, the white striker becomes slower, the other balls become faster. So whenever two objects collide, the one M1 which was faster initially, after the collision will become slower. And the M2 which was slower now will become faster. Interchange type of speeds. Now, let's say after collision the speeds are changed. Its velocity is changed to V1 and its velocity is changed to V2 of second one. Before collision, the speed of m1 was u1 and m2 was u2. Initial velocities were u1 and u2. After collision, their velocities are changed. So for first mass, its final velocity after collision is v1 and for second it is v2. Now this one is faster. And due to that faster speed, now this one going will be going far away from the M1. The M2 will be moving away, farther, will be moving away. So the separation between them will be increasing. So if we want to find with how much speed it is going away, so that again will be equal to difference of both the speed. But now this M2 is moving away, farther away from the M1 now. Initially the M1 was getting closer, was approaching. So that was relative speed of approach. Now here V2 is faster, its arrow is larger. It will be moving away from the M1, M2 will be moving. So that will be relative speed of approach and will be equal to their difference. So U1 minus U1 U2 U1 minus U2 was relative speed of approach. It is the speed with which the M1 is getting closer to M2, approaching the M2. That is why relative speed of approach it is getting closer. And here V2 minus V1 will be the speed with which the M2 is getting farther away, separating from the M1. So that is relative speed of separation V2 minus V1. Beta, from time being, we are no more discussing these two speeds, but they will come in discussion in the next lesson. Now, coming back to this, when these two objects collide with each other, they apply force on each other both. Let's say the force applied on M1 is F1, and force applied on the M2 by the M1 is F2. We said whenever two objects collide, they both apply force on each other. No, we should not say that only bat can hit the ball. Ball also hit the ball. Bat, ball also hit the bat. And when we hit the football with our foot, the football also applies the force on our foot, right? So always according to Newton's second law, whenever two objects apply force on each other, both the forces are equal but opposite. And opposite means minus. One should be positive, the other should be, this is positive negative. It's not necessary that you write negative here. You can write positive here and negative here. Just the real concept, they should have different opposite sign. One is positive, the other is negative. Acha, now, what is the formula for force? Force is rate of change of momentum, means change in momentum divided by time. And formula for change in momentum is m into v minus u. So beta, for F1 is the force on M1. We are using this formula and substituting here. And we will write 1 with all the values like mass M1, V1, and U as like for mass 1 is mass, so first mass is mass was M1, its initial speed was U1, its final speed was V1. Means for first sub object, all the values were with 1. So for first object, all the values, we are writing the same values here with 1 with each quantity. And for second object, we are using the same formula, but here it is 2. with each quantity means m के साथ भी 2 and v and u are also having 2. Clear beta ji? Right? But we are not writing v1 or 2 with t because t is the time of contact that will be same for both. Right? And for that time dividing will multiply here and both will be cancelled. Clear beta? Now minus m1 multiplying, we multiply minus m1 with v1 makes minus m1 v1 and then m2 multiplied with u1 makes m1 u1 and minus minus make it positive. We just now multiplied m1 with both of them. Similarly, we multiplied m2 with both of them and have written here simplify. Now what do? We rearrange them and we write the values of u on one side like this. This minus m2 u2 will become positive on this side, right? Beta, how we are rearranging? We are using writing the values of u on one side. So this m2 u2 which is negative when moved to this side becomes positive. Similarly, we make v1's values of v's on one other side. So minus m1 v1 will become positive on this side, right? So beta, this is the formula. Isn't that the formula we were using in the questions discussed before, right? So we have used this formula in O level as well, but in here we are also doing its derivation. Now, just give it another minute. What does that mean actual? Beta, mass multiplied by velocity give you momentum. So m1 multiplied by initial momentum, initial velocity now, this will give you momentum before colliding. And m2 was moving with speed u2 before colliding. So this is the momentum of first object before colliding, and this is the momentum of second mass before colliding. And when you add now, this means this is the total momentum before collision. And here, V1 and V2s are the velocities after collision. So this is the momentum after collision, and plus means the total momentum after collision, and equal says that total momentum before collision is equal to the total momentum after collision. This proves the total momentum stays the same, right? So this is what we wanted to prove,
Mm.
that total momentum of a system stays the same. Clear, beta ji?
Yes.